Chapter 1 Exercise 1.3 Question number 1. Write the following in decimal form and say what kind of decimal expansion each has. 36 divided by 100. We already know to convert this kind of fraction form into decimal form. Here denominator has 2 zeros. So we should put decimal point before 2 digits. That means we should put decimal point before 36. That is 0.36. So 36 divided by 100 is equal to 0.36. I will show you by simple division method. 36 divided by 100. Here we cannot divide 36 by 100 as 36 is smaller than 100. So we should put 0 and put a decimal point here, and we will put 0 in front of 36, and now it becomes 360 divided by 100. 100's 3's are 300. Now subtract these two. We get 60. Again we put 0 in front of 60. Now 106 are 600. Now we get remainder as 0. Now we should stop doing division because we get remainder 0 and we stop here. So our answer is 0.36 only, and there is no need to further division. Such kind of decimals where we end up with 0 remainders are known as terminating decimals. A terminating decimal is a decimal that ends. It's a decimal with a finite number of digits. Second one, 1 divided by 11. Here 1 is smaller than 11. We cannot divide 1 by 11. So we put 0 and put a decimal in front of 0 and put 0 in front of 1. Now the number is 10. Now also we cannot divide 10 by 11. So we put 0 in front of decimal and put also 0 in front of 10, and now it becomes 100. So 11 9's are 99. So 100 minus 99 is equal to 1. Now we get 1 as the remainder. So again we put 0 in front of 1, and now it becomes 10. Now also we cannot divide it by 11. So we put one more 0 in front of 0.09 and one more 0 in front of 10, and it becomes 100. Here 11 9's are 99. Subtracting both again we get remainder 1. So this process keeps on going and never stops. So this is a non-terminating decimal. Here see the pattern. The numbers are repeating 09, 09, 09. So this is repeating or recurring decimal. This type of decimal never ends and has a repeating number pattern. So it is a repeating decimal. We can write 0.09 bar. Bar means 09 is repeating. Next example, 4 1 by 8. This is mixed fraction. First, we have to convert mixed fraction to improper fraction. You already know that, right? So, 8 into 4 is 32 and plus 1 is equal to 33 divided by 8. So, 4 1 by 8 is equal to 33 divided by 8. Now we can divide this. 8 4's are 32. Now subtract 32 from 33. We get 1 as the remainder. Now we cannot divide further as 1 is smaller than 8. So we should put decimal point here and then take a 0 here. Now it becomes 10. So 8 1's are 8. 10 minus 8, and we have 2 as remainder. Now take 0 and it is 20. 8 2's are 16. 20 minus 16 is equal to 4. Now we have to put 0 and it is 40. So 8 5's are 40. 40 minus 40 and we get 0 as the remainder. As we got 0 as the remainder, we can stop here. So our answer is 4.125. We can say this is a terminating decimal. Example 4. 3 divided by 13. First, we should put a decimal point and take 0 here. Now it is 30. So 13 2s are 26. Remainder is 4 and put 0. 13 3s are 39. Remainder 1. Now even after putting 0, we cannot divide. So we should put 0 here. Put one more 0 here. Now it is 100. 13 7s are 91. Remainder is 9. Put 0. 13 6 are 78. Remaining 12. We put 0. Now 13 9s are 117. So remainder is 3. As you can see, it is not terminating at all and it is repeating. So it is non-terminating but repeating. Fifth one, 2 divided by 11. Here also 2 is smaller number and 11 is bigger number. So 2 divided by 11. We have to put a decimal point here and take a 0. Now it is 20. 11 ones are 11. 20 minus 11. So remainder is 9. Now again we have to take 0. Now it is 90. So 11 8s are 88. Now 90 minus 88 is equal to 2. 2 is the remainder. Again this process goes on and on forever. This division never stops. This is non-terminating because we cannot stop the division. See the answer. 0.1818. It is repeating. We can write it as 0.18 bar. So this type of decimal is called non-terminating and repeating decimal. Example 6. 329 divided by 400. See here, 329 is smaller than 400. So we have to put a decimal point here and put a 0 here. Now it is 3290, isn't it? 408s are 3200. Now subtracting these two, we get 90. Again we put 0. Now we have 900. So 402s are 800. So 900 minus 800, we get 100 as remainder. We put 0. Now we got 1000. 402s are 800 and we get remainder as 200. We have to put 0 here. Now we have 2000. So 405s are 2000. We got remainder as 0. So we can say that this is a terminating decimal, isn't it? Chapter 1, Exercise 1.3, Question number 2. You know that 1 by 7 is equal to 0.142857 bar. Can you predict what the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing the long division? If so, how? Hint: study the remainders while finding the value of 1 by 7 carefully. Solution: yes, we can predict the required decimal expansions. Here given 1 by 7 is equal to 0.142857 bar. On dividing 1 by 7, we find that the remainders repeat after 6 divisions. Therefore, the quotient has a repeating block of 6 digits in the decimal expansion of 1 by 7. So, to obtain decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7, multiply 142857 by 2, 3, 4, 5 and 6 respectively. To get the integral part and in the decimal part, we take block of 6 repeating digits in each case. Hence, we get 2 by 7 is equal to 2 into 1 by 7 is equal to 2 into 0.142857 is equal to 0.285714. 3 by 7 is equal to 3 into 1 by 7 is equal to 3 into 0.142857 is equal to 0.428571. 4 by 7 is equal to 4 into 1 by 7 is equal to 4 into 0.142857 is equal to 0.571428. 5 by 7 is equal to 5 into 1 by 7 is equal to 5 into 0.142857 is equal to 0.714285, and 6 by 7 is equal to 6 into 1 by 7 is equal to 6 into 0.142857 is equal to 0.857142. Okay, let us move on to the next question. Question number 3. Express the following in the form P by Q, where P and Q are integers and Q is not equal to 0. Example 1. 0.6 bar. Solution. Let x is equal to 0.6 bar or x is equal to 0.666 and so on. We can take, this is equation 1. On multiplying equation 1 by 10, 10x is equal to 6.66. This is equation 2. Subtracting equation 1 from equation 2 implies 9x is equal to 6. Therefore, x is equal to 2 by 3. Example 2. 0.47 bar. Let x is equal to 0.47 bar or x is equal to 0.4777 and so on. This is equation 1. Multiply equation 1 by 10. We get 10x is equal to 4.777 and so on. This is equation 2. Again multiplying equation 2 by 10, we get 100x is equal to 47.777. This is equation 3. Subtracting equation 2 from equation 3, we get 90x is equal to 43. Therefore, x is equal to 43 by 90. Example 3. 0.001 bar. Let x is equal to 0.001 bar or x is equal to 0.001001 and so on. This is equation 1. On multiplying equation 1 by 1000 implies 1000x is equal to 1.001001 and so on. This is equation 2. On subtracting equation 1 from equation 2 implies 999x is equal to 1. Therefore, x is equal to 1 by 999. Question number 4. Express 0.999 and so on in the form P by Q. Are you surprised by your answer? With your teacher and classmates, discuss why the answer makes sense. Solution. Let x is equal to 0.999 and so on. This is equation 1. On multiplying equation 1 by 10 implies 10x is equal to 9.999 and so on. This is equation 2. On subtracting equation 1 from equation 2 implies 9x is equal to 9. Therefore, x is equal to 1. Yes, we are surprised by our answer. Question number 5. What can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. This is simple division. You already know that, right? After doing this division, our answer is 0.05882352941176647 and so on. As you can see, here we started with 1 and we are back to 1, and from here onwards it is going to repeat in the same sequence. Thus, 1 by 17 is equal to 0.05882352941176647. Hence, the required number of digits in the repeating block is 16. Hey guys, if you have any doubts, please drop in your comments. Chapter 1, Exercise 1.3. Question number 6. Look at several examples of rational numbers in the form p by q, q not equal to 0, where p and q are integers with no common factors other than 1 and having terminating decimal representations, expansions. Can you guess what property q must satisfy? Solution. Let various such rational numbers can be 1 by 2, 3 by 4, 5 by 8, 19 by 20, 36 by 25, 7 by 125, etc. In all cases, we think of the natural number which when multiplied by their respective denominators gives 10 or a power of 10. First we will take 1 by 2. Here denominator is 2. Now to get number 10 we have to multiply by 5, which is a natural number, and we get 1 by 2 into 5 by 5 is equal to 5 by 10 is equal to 0.5, and we get terminating decimal. Next we will take 3 by 4. In the denominator we have number 4. To get 10 or multiple of 10 we have to multiply by 25, which is 5 into 5 is equal to 5 square. So we get 3 by 4 into 25 by 25 is equal to 75 by 100 is equal to 0.75. So here q is written as 5 square and the result is a terminating decimal. So similarly 5 by 8 can be written as 5 by 8 into 125 by 125 is equal to 625 by 1000 is equal to 0.625. Here the denominator 1000 can be written as 8 into 125. So 8 can be written as 2 into 2 into 2 is equal to 2 cube, and 125 can be written as 5 into 5 into 5 is equal to 5 cube is equal to 2 cube into 5 cube. So denominator is in the form 2 raised to n into 5 raised to m. Next one is 19 by 20. Here 19 by 20 can be written as 19 by 20 into 5 by 5 is equal to 95 by 100 is equal to 0.95. Here denominator 100 can be written as 95 by 4 into 25. Here 4 can be written as 2 into 2 is equal to 2 square, and 25 can be written as 5 into 5 is equal to 5 square. So 95 by 2 square into 5 square. The result is again a terminating decimal. So again denominator is represented as 2 raised to n into 5 raised to m. Therefore in all cases the q or the denominator takes the form 2 raised to n or 5 raised to m or 2 raised to n into 5 raised to m. Therefore to get terminating decimal the q must be in the form 2 raised to n or 5 raised to m or 2 raised to n into 5 raised to m, where m and n are natural numbers. Question number 7. Write 3 numbers whose decimal expansions are non-terminating, non-recurring. Solution. All non-terminating and non-recurring decimals are irrational numbers. We already know that, right? So we can take irrational numbers like square root of 3 is equal to 1.73205080756888 and so on. Square root of 5 is equal to 2.23606797749979 and so on. Square root of 7 is equal to 2.64575131106646 and so on. Square root of 58 is equal to 7.615773105863 and so on. Square root of 127 is equal to 11.26942766958446 and so on. Question number 8. Find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. Solution. To find irrational numbers, firstly we shall divide 5 by 7 and 9 by 11. So you can get it as shown here. So 5 by 7 is equal to 0.714285 and so on. And 9 by 11 is equal to 0.8181 and so on. Therefore, 3 irrational numbers in between above 2 numbers can be 0.720, 7200, 72000 and so on. Second one, 0.760, 7600, 76000 and so on. Next one, 0.80, 800, 8000, 80000 and so on. You can try these patterns. It is so easy. Question number 9. Classify the following numbers as rational or irrational. Solution. First one, square root of 23 is equal to 4.79583153 and so on. So, the decimal expansion is non-terminating and non-recurring. Therefore, square root of 23 is an irrational number. Second one, square root of 225. 225 is a perfect square of 15 and we can write it as 15 by 1. That is, we are representing it as P by Q form. So, it is a rational number. Next one is 0.3796. It is a terminating decimal. So, it is a rational number. Next one is 7.478478 and so on. We can write it as 7.478 bar. The number 7.478478 and so on is non-terminating but recurring. It is a rational number. Fifth one. See here. The decimal expansion is non-terminating, non-recurring. So, this is an irrational number. I hope you understand these solutions to the questions. If you still have any doubt, please leave a comment. I will respond to it. Work hard, dream big, never give up. Thanks for watching.